Hello and welcome to tutorial number 11 on multithreading in Java from caveofprogramming.com. And this tutorial is going to be on Deadlock and a couple of ways you can solve it, including using the try-lock method of the reentrant lock class, which we looked at in the last tutorial. So, as in the last tutorial, I've got a little runner class set up here, and my main program is set up so that it runs the first thread method of runner and the second thread at the same time in different threads, and when the threads are finished it calls the finish method of runner. So this is running in one thread at the same time this is running in another thread, and when the threads are finished this is called. I've also got a account class here set up, and account just has a balance and it has a method called deposit which adds to the balance by the specified amount. It has a method called withdraw which subtracts the specified amount from the balance. There's a getBalance method, and there's a static transfer method which takes two account objects and withdraws the specified amount from the first and puts it in the second account. So pretty simple. I hope you're with me so far. And in my runner class I'm going to create two accounts. So account ac1 I'll call it equals new account. And let's say private account ac2 equals new account, like this. And in the finished I'm going to say account1 balance, and that's going to be ac1.get balance. And I'm also going to have a account2 balance here. And I'm going to have a total balance here. So total balance will equal account1.getBalance plus account2.getBalance. And if I run that now, of course, I'm going to find that, if I run that now once I've got rid of this error, I'm going to find that both accounts have their initial balance of 10,000 still, and the total balance is going to be $20,000 or euros or whatever you like. So now let's make this a bit more interesting. And in the first thread I'm going to have a loop here which is going to loop 10,000 times, and it's going to just make a bunch of random transfers from the first account to the second account. So I'm going to use the random class here to create random numbers. And I will say that I'll do account.transfer, and let's transfer from account 1 to account 2 a random amount of up to 100, like this. And in my second thread I'm going to do the same thing, but I'm going to make random transfers from account 2 to account 1. And the point of this is to sort of, of course the real point is to illustrate a problem in multi-threading, but the idea is that this is some sort of sprawling banking system, and actually there are not going to be two threads in reality, but a bunch of threads making random transfers between lots and lots of different random accounts. And let's run this, and the total balance should be 20,000, but it's not, because of course I've got multi-threading issues as usual. And so what I'll do is, it should be 20,000 because I'm only ever transferring. I'm not actually, if I withdraw from one account I always transfer it into the next account. So to fix that I could use a nested synchronized block where like the outer synchronized block, let's say, could acquire a lock for account 1 and the inner one could acquire a lock for account 2. But partly because I don't like nesting things too much, I'm going to use the reentrant lock class instead. So let's say private lock 1, and this will be a lock for account 1 equals new reentrant lock, and this is the class that we looked at in the last tutorial. And let's have a lock 2 which is equal to new reentrant lock. And what I'll do is, before I do a transfer, I need the locks associated with both accounts. So I'll say lock1.lock and lock2.lock, and I mustn't forget to unlock, and I'll better do that in a finally block just in case my account.transfer throws some kind of exception. So I'll say finally here, lock1.unlock and lock2.unlock. Okay, and now let's copy that after doing Control-Shift-F to format my code a bit, and I'll have the same thing in here, and except that I'll transfer from account 2 to account 1. Now if I run that, it's going to work and it'll solve my multi-threading issues, so now I'm not losing money all over the place, which is good. But you can imagine that if this is some huge system and you have a lock associated with each account, not that you would, but imagine if you did. In fact, you might, come to think of it, then you probably won't know which account you're going to transfer from an account and which account you will transfer to in advance. You just know that you're going to be given two accounts and told transfer money from one account to the other account. So you're going to get the lock associated with one account and then the lock associated with the other account. And the point of that is that what I mean to say is that you might end up locking first. If you're transferring from account 2 to account 1, it makes sense that you might end up locking first the lock for account 2 and then the lock associated with account 1, like this. So basically we're doing our locks in different orders, and if I run that, sooner or later you'll have what we call deadlock. And the reason for this is so the program's just waiting and it's not doing anything, it's just frozen. The reason this has occurred is that you might even guess that the first thread has at some point or other acquired lock 1, and the second thread has acquired lock 2, and then the first thread has tried to acquire lock 2, but it can't because this has got lock 2, and this is trying to acquire lock 1, but it can't because this has got lock 1. So neither of the threads can proceed because each of the threads needs a lock that the other thread has got, but both threads has already got one lock, and it's not going to give it up because it won't give up the lock that it has got until it can get the other lock, and then later on it will do the unlocks. So both threads have got one lock and neither can get the other lock, and this is deadlock. And deadlock can occur if you lock your locks in different orders, and it can occur not only with reentrant lock but also with nested synchronized blocks. And when I say nested synchronized blocks, of course it's possible that you'll have one synchronized block in one method and that will call another method, which in the second method you have another synchronized block, so they're not necessarily going to be obviously nested. And there are two solutions to this that I know of, and one of them of course is just to always lock your locks in the same order, and that will ensure that you don't get deadlock. Another possibility is, well, let's imagine here that I want some kind of method that can acquire the locks in any order and it will never cause deadlock. So imagine that, if you will. Let's try to code such a method. So I'll say public, well, let's make it private void acquire locks, and you can pass the locks that you want to acquire locks. So I'll say lock first lock and lock second lock, and the job of acquire locks is to acquire the first lock and the second lock in such a way that deadlock can't be caused. So I'll say here, I'll replace my previous code with acquire locks, lock 1, lock 2, and I'll have the same again in the second thread here, except that I'm going to try to lock 2 and lock 1. And the way to do this is you can use something called try lock, which is a method of reentrant lock that returns immediately, and it returns true if it's got the lock and false if it hasn't. And we're going to do that in a loop because I want this acquire locks to really make sure it does acquire the locks, and I don't want it to return in this case until it does acquire them. And in reality, of course, you might want to think about timeouts and that sort of thing. But here, let's have a while true, and here I'll try to acquire the locks, and if I can't acquire the locks not acquired, then I'm just going to have a thread, I'm just going to sleep for long enough that one of my threads might unlock the locks that it's got, to give me a chance of acquiring them on the next kind of iteration around this loop. So to acquire the locks, or to attempt to acquire the locks, I'll have a try block here, and in this try block, well, let's have a couple of booleans. So I'll say boolean got lock, maybe got first lock, and this will be set to true if I can get the first lock, and we'll have get second lock equals false too. And in the try thing here, we'll say got first lock equals first lock dot try lock, like this. And you can see that try lock also has a version that has a timeout, which you might want to use in a real situation, but I'm not going to use that here. I'm just going to use try lock, and we'll say second got second lock here equals second lock dot try lock. So second lock dot try lock. So try lock will return immediately, and it will only return true if it's got the locks. Otherwise, it'll be false. If it returns false, I need to unlock the locks, of course, and go around the loop again. So in this finally block here, which will execute even if one of these throws an exception, I will say, well, if I've got my locks, if got first lock and got second lock, then we've done what we wanted to do. So I can just return from the function, and it works. If I'm down here, I haven't got the locks, or I haven't got at least one of the locks. So I want to say, but I want to make sure that I unlock whatever locks I have got. So if I say here, if I've got the first lock, then here I better unlock it. First lock dot unlock, to give other threads a chance to acquire it. And here, if I've got second lock, and remember this bit's only happening if I haven't got both the locks, then I'll do second lock dot unlock, and yep, that should be got second lock. Okay, so basically I will try to get the locks in a try thing, and I'll have a finally which will always execute, and I'll check here in the finally. If I've got both the locks, I'll return from the method because it's now acquired the locks. And if I haven't got both the locks, then I need to check each one and unlock it if it's locked, because I want to give other threads a chance to get those locks. And if I don't get the locks and I don't return, then I'm just going to sleep for a bit, and I'll try again in another iteration of the loop. So now acquire locks will always acquire the locks safely, and we won't get deadlock. Okay, so quite a lot for this tutorial. This code is on caveofprogramming.com as always, and do join me for the next tutorial when I'm not sure what we will look at yet, but possibly semaphores or possibly something else, because there's still quite a lot on multithreading to cover. Although we've covered a lot, and we've covered enough to get you through most situations that you'll encounter in multithreading, I should think. Okay, so join me again for next time, and until then, happy coding.